Good day, grade 12 learners. In today's video, we are going to do a review of the exam that you recently wrote for Mathematics Paper 1. So we'll start with question 1 here, which we all know that it looks at algebra. And there's various ways in which we are solving here algebraic equations by solving for x. That's 1.1. So for this year's exam, you were given here the first equation 1.1.1, x plus 5 multiplied by x minus 2, and they say this is equals to 0. When you look at this equation, already it is factorized, so it means they've done a step for us, of factorizing the standard form of a quadratic equation. So it means at this stage we will say that either the x plus 5 should be equals to 0 or the x minus 2 should be equals to 0. And therefore x should be equal to minus 5, or x should be equals to a positive 2 there. And you can see really this is only for 2 marks because they only mark the 2 correct final answers. The next question looks at a quadratic equation here, which we are given to be the 5x squared plus 2 being equals to negative 9x. And as usual here, they'll tell you that correct to 2 decimal places. That is a hint to say use a quadratic equation. But before we can really get to the quadratic equation, the first thing that we need to do is to write this equation in a standard form of a quadratic equation. So I'm going to have here 5x squared plus the 9x. So this 9x, when it comes to this side, it will be positive. And we still have a positive 2, and this is equals to 0. Now, this is in a standard form. And what this means now is that I can pull now my quadratic equation where I'm going to have minus b plus or minus the square root of b squared minus 4ac all over 2a. Then from here, this question becomes a simple substitution problem, because what we really do here is that we take the ax squared plus bx plus c to be equals to 0. So this is the same as that. Our a here is a 5, our b here is a 9, our c here is a 2, and I'm going to do exactly that. So the b, we're saying that it's a 9, I'm going to have a minus 9. So this minus here and the b here is a 9. Then I'm going to have the plus or minus, then we're going to have the root of 9 squared. So this is 9 squared minus 4. Then our a, remember we said it's a 5. So the a here is a 5. And our c is indeed a 2. We said this is a 2. Then we're dividing this whole thing by 2 times a 5 because the a is a 5. From here, this becomes very, very, very boring, because now we are going to punch the whole thing in a calculator. We're having a minus 9. I'll start with a plus, then we have a root of 9 squared here, minus 4 times the 5 times the 2 all over 2 times the 5. And my first answer here becomes that x, therefore x is equals to negative 0.26. When we round that off, the 9 will throw in the 1, it becomes the 5 becomes a 6. Then the other option, the other solution that we have really is to put a negative there, and this would mean that the x is then equals to negative 1.54, and those are your 2 solutions or roots to this equation. This is 4 marks. The first mark will come from writing the standard form. The second mark will come from substitution, 1 mark for each correct answer of x, the value of x. Now we go on to the next question here, which is 1.1.3, where we are given the inequality. So we are doing this now. We are given the inequality there, 8x squared is greater than 2x. So we are on 1.1.3, we have 8x squared being greater than 2x. Okay, so here what one can do really is to see that the 8 and the 2 are related. 2 is a factor of 8, it can go into 8. So that means I can divide by the 2 since it is divisible in both 2 and the 8. So here the 2 would cancel each other. It goes once. I'm having 1 over 1, which is an x. And this side 1 goes once, but here it will go 4 times. So at the end of the day, I'm having here 4x squared being greater than x. And as usual, when you have an inequality, you want to put all the terms on one side. So that means I'll take the x to this side so that I have a standard form of a quadratic equation here, or inequality. So I'm going to have the 4x squared minus the x being greater than 0. So this will become a negative when it comes to this side. Now at this stage, what we can do really is that we can factorize here. I can take out the x as a factor, a common factor, so that I have an x here minus 1 is greater than 0. Remember, if I multiply this back, I'm going to have a 4x squared. Then if I multiply back, I'm going to have a negative x. So x is a common factor there. Now at this stage, we are then going to look for the critical values, CV. The critical values occur when this product is actually equal to 0. When it's equal to 0, that's where we get our critical values. And so this would mean now that x will therefore be equals to 0, or x it will be equals to 1 over 4. Remember what I'm doing here. I'm setting this to be 0, then I'm setting this whole thing to be 0 as well. So that I take the 1 to this side, it becomes positive. Then I'm having 4x is equals to 1. Then I divide by the 4 both sides so that I have the x and I have the 1 over 2. That's how I got that critical value. Now, the critical values assist us in determining or constructing intervals. I'm going to then put these critical values here to say I have a 0 here. I have a 1 over 4. These critical values assist me to then break the number line into 3 intervals. This interval here and this interval and that interval. Obviously, this interval on the far left is defined by saying x is less than 0. In other words, we're looking for the values of x that are smaller to 0. But here, we're saying x is between 0 and 1 over 4. And very important, these numbers here, 1 over 4 and a 0, they are not included. We don't include them because we are looking at inequality that is greater than 0 there. And on this side, the value of x will really be greater than 1 over 4. The next step would be then to test our inequality on the intervals. So that means here I can take any value that is on this interval and put it here on our inequality. Remember that this inequality is saying that we are looking for the values that are positive. So the values that are greater than 0 are values that are positive. So any value of x that we put here that is positive will actually satisfy this inequality, will make it to be true. So we want to test that if I take a value in this interval and put it here as a value of x, will I get a positive or a negative number? So I'm going to do exactly that. I'm going to take negative 1 because negative 1 falls in the interval x is less than 0. So we're going to have a negative 1 here squared minus, we're having a minus 1. Very important here, remember, we're having a negative x there. Then I get a positive number there. It means, so what I look is the sign, not the value. It means this side we have a positive number. You can do this by taking negative 3, negative 2, negative 10, negative 100. Any value that is in here should give you a positive sign. It should be a positive inequality. Now, when we look at the middle part here of the interval, I'm only having 0 to 1 over 4. And 1 over 4, I know it's roughly 0.25. So I can take 0.1 here. I can experiment with 0.1 because it is less than 1 over 4, 0.24. And that says we're going to have negative. So it means the numbers that are here are negative. So any number that you take in this interval will be negative. And then above the 1 over 4, this side here, I'm going to then take, let's say, a 1. I can use a 1 in there because 1 is greater than the 1 over 4. Then I get a positive again. So you can use a 2, a 5 as well. All of them should give you a positive. Now, remember, our inequality, we are looking at it where it is positive. So the inequality is positive in this interval and that interval. That means my solutions, they range from 0 going to negative infinity, and the 0 is not included. 0 should not be part of the inequality because we are not saying greater or equal to. And also this side here, we are also not including the 1 over 4 and we're going to positive infinity. So that means my values of x should be x is less than 0 or x is greater than 1 over 4. Now, there is another way in which one can do this inequality. And I'm just going to share with you because, we're exploring the memo here. Remember, we are given x squared is greater than 2x. So what I can do here is that I can take the 8, I can keep the 8 as it is and take the 2 to be this side so that it becomes a negative 2x. So all I did is that I took the whole thing to this side, then it became negative 2x. Now I take out here a common factor of 2x so that I have a 4x here minus a 1 is greater than 0. Remember, again, if I multiply this and that, I should get the 8x squared. Then if I multiply this, I should get the negative 2x. Now at this stage, I can then look for my critical values. I can say CV will be equal to what? X will be equal to 0 or x will be equal to 1 over 4. I hope you are able to see that if we set up this to be equals to 0, we are going to get a 0, because if you say 2x equals to 0, you divide by 2 on both sides, you still get a 0. And of course, this one we have done it. If you say this is equals to 0, you get the 1 over 4, I mean to say. Now, at this stage, the other method that I wanted to check with you, to help you with, is that we can draw a graph actually here. We can do it using a graph method where we say we are having a 0 here. This is the x-axis, this is the y-axis. Now, we are saying that this graph has intercepts because the critical values occur when this thing is equal to 0. So it means it's where this function, you can look at it as if it's a function, is equal to 0. That means you get the x-intercept. So these values will represent the x-intercepts. So my x-intercepts are here at 0 and the other one occurs here at 1 over 4. And both of them are not included. So we do a circle like that. They're not included. And when we look at our function, if you look at it from here, you can see that this is a happy graph. It's a happy parabola because it has an x squared there. And it's happy because the 8 here is positive. So that means my turning point will be somewhere here. You don't really have to find that value of the turning point. So it means this graph will go uphill like that. And here at 1 over 4, it's not included. It's not defined. And then it will continue going like that until infinity. And it will also go here, and here at 0 is not included. It will go like that until infinity. Now, when you look at this graph, you can see that on this side of things, the values of y, if we look at the values of y, they are actually positive. So this graph is positive this side. The same is true when you look at this graph here. The values of y here, if you put the values of y here, these are the values that we map with x. If you put x, you get that value of y. All these values here, they are positive on this side and this side. So it means the graph is positive here. However, the values of y, when you come to the bottom part of this parabola, if you look at the bottom part here, the values of y here, they are actually negative because, if you put the y value here, you get a negative number. And the same is true this side, you also get a negative number. If you put, again, y there, you get a negative number from both sides. So it means the values of y here, they are negative for every value of x that you put in there. So it means the graph, this side here, it's negative in the shaded area here with a pink highlighter. And we are saying we're looking for the function where it is positive again, where this function that we have drawn is positive, is greater than 0. So it means it is positive on this side and this side. And obviously, when you look at this side, what are the values of x? Is from 0 to infinity. Do you see that? 0 to negative infinity. So that means my solution here would be x is less than 0. Because every number that is less than 0, it will go until infinity. Or the other option would be that it will be from 1 over 4 to positive infinity. It goes to positive infinity here. So x will be greater than 1 over 4. So you get the same solution. And, this question is marked out of 4 marks as well. So I think your first mark will be writing the standard form, because if you look at this is a standard form. And you'll get another mark, 2 marks for writing the final answer. And I think the other mark will be for you to do the CV, critical values, and also constructing either the number line or doing the graph, because the methods are the same. Now, the next question that you were given for your exam is 1.1.4. So this one here, very beautiful question, interesting question. So we are given here (1.1.4) 2 times 2 to the power 2x minus 9 2 to the power x plus a 4 is equals to 0. The first thing that I will advise to do here is that you say 2 and then you write this as 2 to the power x, and here we're having a 2. So basically what I'm doing here is that I'm applying a rule that says that if you have a to the power n times m is the same as saying a to the power nm. So the exponents there, my indices, they multiply each other so that I have nm. So I'm doing the reverse because we are starting with this. I'm going backwards like that. We are starting already with 2x nm. Then I'm breaking it back to say this can be written as a to the power x and the 2 outside. I hope that's clear. Then the second thing that I'm going to then do after this is that, I see a quadratic equation for me here. At first glance, when I saw this equation sitting like that, what I saw on my mind was ax squared plus bx plus c. That's what I saw. And that's what I'm trying to do here. I'm trying to bring that x squared there. Now, what I'm going to do here, and I think in the prediction I did something similar like this, where, I anticipated that you will have a question where you have to use, some people call it the K method or the substitution method, where we say let a be equals to 2x. Do you see that this 2 to the power x is unique in that if I change this equation, I'm going to then have 2 to the power a squared. Remember, when I put the a here, I'm going to have the a, then the 2 will multiply the one visible one, then you'll have the a squared. Now here we then have 9a, because I'm just substituting this with an a, and I'm having a plus 4 is equals to 0. Now this looks like a standard form of a quadratic equation really, and what we do from here is that we can factorize this. This can be really factorized so that I have now 2a, then I have an a here, and the factors of 4 that I see here would be 4 and a 1, because I have a 2 here. So if I use a 4 and a 1, I say 4 and I put a 1 here, I can see that if I multiply 4 and a 4, I will get a positive 4 if and only if both of them are negative, because if you say negative 1 times negative 4, that should give you a positive 4. But you must check that if I say 2a times negative 4, I get a negative 8a. I get a negative 8a. Then if I say negative 1 times the 2, I'm doing this here, I get a negative a. Negative a, 8a, negative a, it will give me a negative 9a, and this is this negative 9 here. So that's how I factorized that. Now from here, we're then going to say either 2a minus 1 is equals to 0, or a minus 4 is equals to 0. And really what I'm going to do at this stage, that I can bring back the a. I can resubstitute the a. Remember, we know that a is equals to 2 to the power x. So I'm going to say here we're having 2 to the power x minus 1. Well, maybe this minus 1, I can actually take it to the other side. I can say it's going to be plus 1. So I'm taking the 1 to this side. And here we're having or. I'm going to put here the 2 to the power x, and I'm going to say it's equals to 4. Remember, I'm taking this 4 to that side. It becomes a positive 4. Now, when we continue here, I'm going to apply the laws of exponents here. I'm going to keep the base 2, then I'm going to add my exponents, and this equals to 1. And this side, I'm going to have a 2x is equals to 2 to the power 2. Remember, 4 can be written as a power of 2 to the power 2. And here I'm going to have 2x plus 1 is equals to 2 to the power 0. Remember that any number raised to the power of 0 is 1. And I'm using here the 2 because I know that if the bases are the same, the exponents must be the same. I'm using that rule where we say then, therefore, this would mean that x plus 1 should be equals to 0. And this means the final answer should be negative 1. Now, when we come to this side, we're going to apply the same rule to say if the bases are the same, the exponents must be the same. So this would mean that x should be equals to 2. And those are your roots. There is another way of looking at this. You know, when I'm at this stage, there are many ways of solving these problems. When I'm at this stage, what I can do really is that, you know, an alternative, or I can say 2a is equals to a 1. So what I've done, I've taken this 1 to this side, it becomes positive 1. And what I do is that I then divide both sides by 2 so that I have 1 over 2. And then I substitute back my a, which is 2 to the power x is equals to. Remember, there's a rule that says if you have 1 over, you can write this as 2 to the power negative 1. You know the laws of exponents where we say if you have a to the power negative n is the same as 1 over a to the power n. I'm really applying that rule here, but again, I'm going backwards. I'm starting with this, I'm taking it back to that. So that's what I've done here. At this stage, you can see that I have the same basis. It means the exponents must be the same. Therefore, x should be equals to a negative 1. And that's how you would get the same answer of negative 1 in both cases. And your solutions then are those. This is 4 marks. So you'll get a mark firstly for writing this in a standard form. You know, substituting that a and it becomes standard form. You'll get another mark for factorization. Then you'll get a mark for the 2 final answers. Do you think that you have solved it in a different way, and what answer did you get? Share with me on the comment section. Now we are going to go to the next question, which really looks at 1.5, where we are given the root of that whole thing and for 5 marks. Let's see how we can solve that problem. Now I'm given here 1.1.5. We are given the root of 1 over x plus a 2. So the 2 is inside that square root, and then we're saying this is equals to 1 over the root of x. Again, there are many pathways in which this problem can be solved. You can, do this in very, very different ways if you like. I'm going to share just the simplest and easiest way that will save you time, because some ways will be much more longer. I don't know what method you used. I hope you got to the final correct answer. Now, the first thing that I'm going to do with my method is that I'm going to square both sides so that I remove at least the first square root. Remember, when we square here, the square root will fall out. The first square root will fall out, and I'm going to have a square root of 1 over x plus a 2 this side. So this here will make this square root to cancel, because remember, the square root is the same as 1 over 2. So the 1 over 2 would cancel, and I'm left with only the inside part here. But when we square on this side, we are going to have here square. 1 squared will give me a 1. And when we say this squared, because remember, I'm using a rule that if you have a over b and you're squaring this is the same as a squared over b squared. So when we square the bottom part here, the root would also cancel, so that I'm left with an x there. Then the second thing that I'm going to do is that I'm going to transpose the 2 to the other side so that it becomes negative 2. So I'm going to have here a root of 1 over x is equals to 1 over x minus 2. When it's like this, it becomes easy for me to then square again for the second time. I'm going to square on both sides. What I do on the left, I do on the right. Now, when I square this side, the root would cancel, and this would become something else. It will expand. I'm going to write that down so that we can follow each other here. So here we're going to have 1 over x minus 2 all squared. Now, if you look at this, it's a binomial, and there's a shortcut of expanding this. So we're going to say 1 over x is equals to, the shortcut says we square this first. So we're going to square this. And when we square that, it's going to be 1 over x squared. Remember again, the 2 will square the 1, and it will square also the x, according to the rule that I've just explained now. Now, the rule says that we take the 2, we multiply it with 1 over 2. So I'm going to multiply here by 1 over x, I meant. Then we multiply again by the negative 2. So we're going to multiply by the negative 2. And obviously you can see this is over 1 over 1. Now, when we say 2 here, multiply by 1, multiply by negative 2, I'm getting a negative 4. Then if I say x, 1 minus times x times 1, I'm going to have here an x. So that means now our answer here for the middle part, it will be a negative 4 over x. Then the last part of the rule says you square the negative 2. You square that, and this should give me a positive 4 there. Now, when it's like this, what I'm going to do is that I'm going to multiply each term on the right-hand side and also the left-hand side, because what I do on the left, I do also do on the right. I'm going to multiply by this highest common denominator, right? So I'm going to multiply by x squared. So I'm going to multiply here by x squared. The x squared and the x squared will cancel. So I'm going to be left with 1. Then I'm going to multiply here again by the x squared, so that this cancels. I'm having only 1. So I'm going to be left with an x here. So it means I'm going to have a minus 4x. I'm going to multiply also here with the x squared. So I'm going to have plus 4x squared. Then we do the same thing on the left, going to multiply by x squared. Here it will cancel. I'm going to be left with 1. So it's only going to be an x this side. So that is where my now equation have reduced down to. From here we can group terms, where I'm simply going to take the x to this side, so that I'm going to write this in a standard form, rearrange it so that I'm starting with the 4x squared. Then I'm having here the negative 4x. This, when it comes to this side, it becomes a negative x. So this is going to be negative 5. Negative 5x, and then I'm having a plus 1. The plus 1 is just the way it is there. Then the whole thing now becomes equals to 0, because this is no longer on the left hand side, it is moved. Now when we are here, I think we can pretty much quickly factorize this into 4x and an x there. And I think my factors here are easy to determine. It's a 1, so I'm going to have a 1 and a 1. The tricky thing will be to determine whether they're positive or negative by looking at this guy here. I can see that if I say this times this, I'm going to get a 4x. Then if I say this times that, I'm going to get an x. But I need to combine these two so that I get a negative 5. So if I have a negative 4x and negative x, they're going to give me a negative 5x, which is this. So it means both of them should be negative there. And this would then mean that x is equals to a 1 over 4, or x is equals to a 1. However, when you are at this stage, you have to realize that these two values here, we have to test them if they satisfy the original equations. Because remember, we had a root sign there, just like when we have a fraction. You then have to test if these solutions will make the equations to be true. What I mean by that is that I'm going to take the 1 over 4 and substitute that in place of x and also this side, and test if the left-hand side is equals to the right-hand side. And if they are equal, it means that value of x is true, it's a solution for that equation. To do that, I'm going to do the root of 1 over. Here we're having 1 over 4. And we're adding a 2 there. And then we get a value of a 2. So this side here, we have a value of 2 on the left-hand side. And we test again the right-hand side, where we're having a 1 over the root of 1 over 4. Because remember, I'm putting my value of 1 over 4 and then I get a 2. So it means this solution satisfies the equation. So this would be our answer. It's correct. Now we have to test the 1 now. So again, if we come here and we say that we have the root of 1 over 1, and we are adding a 2 here, I get the root of 3 on my left hand side. And if we then test the right hand side, I'm going to have the root of 1 here, then I get a 1. Can you see that these two are not equal? The root of 3 is not equal to 1. So it means we have to reject the value of x to be 1. X cannot be 1 because it does not satisfy the equation. It does not make it to be true. And definitely you will then get your whole 5 marks for squaring the first part and squaring the second part, putting it in your standard form. And both these final answers will give you 1 mark and 1 mark. And that should be a total of 5. Okay, now when we move along to the last question, it says here it's 1.2. I think they say they give us simultaneous in a different, unusual way. But again, it's a very easy way, you know, because, I mean, they just wrote everything in weights and you just have to convert that to equations that we can work with and solve. Now, here they say calculate the values of x and y if, so the first part here, they say if x is the sum of 2 and y. Now, let's start by fixing the word sum. When we say sum, it means a number that you get after addition. So if I say the sum of 2 and a 3 is a 5, the sum is this number, is a number that you get after adding 2 and 3. If I say the sum of 8 and 1 is a 9, the sum is this number that you get after adding 8 and 1. Right, I hope that makes sense. Let us use that to solve this problem. We're saying x is, meaning is equals to the sum of 2 and y, meaning if I add 2 and y, I get x. X is the sum. Right, it's a number that I get after adding those two. Immediately I can say this is equation 1 because of course we know that this is simultaneous, and I can see this equation already is sitting in a simplified form. It says x is equals to. So it's something that I can call equation 1. I don't need to simplify or take things to the other side. Now the second pointer says to us that 5 times the product of x and y is 6 more than the square of x. Okay, again, let's start here. A product, when we say a product, what do we mean? Well, a product is a number that you get after multiplication. So if I say 2 times 3 is equals to 6, the product is this number, is a number that I get after multiplying the 2 and the 3. Then I get that as a product. If I say perhaps 8 times 1, this will be equals to 8. The product is this number. So let us use the same logic for the first part of the sentence. They're saying here 5, so we're having 5 times, meaning we're multiplying the product of x and y. So 5 multiplies the product of x and y, meaning x times y. Remember, x times y, whatever number that I get after multiplying those two is a product. So it means these two are multiplying each other. And we are saying 5 times that product. Then we're saying is, meaning is equal to 6. We're having a 6 more than x squared. Now when we say 6 more, it means we are adding, we are increasing the 6 by what? The x squared. So this 5 times the product of xy is 6 more the square of x. Now from here I can just write this so that it's sitting like xy. I'm just removing this and writing it by space because space means multiplication. Then I can say this is equals to x squared, and I can then call this equation 2. Then from here, it looks like something that you already know we've been working with, throughout the year in different question papers. I will then simply say substitute equation 1 into equation 2, so that now I have the 5y. So we're having the 5y here. Then our x we're saying is a 2 plus y. What have I done here? I've taken this equation 1, which is 2 plus y, substituted that into the x. There it is, and I'm having the y there. And we're saying this is equals to 6 plus, now here we're going to have a 2 plus y squared. Again, I'm substituting this whole thing in the place of x. And from here we can then simplify this. Obviously, when you multiply these two, you can see that you're getting here a 10y. Then if you multiply these two, I'm getting a 5x squared plus 5y squared. 5y squared, not x. And this is equals to 6. And again, here we're going to do our shortcut method where we start by squaring the 2 so that it becomes a 4. Then we take the 2, we multiply it by the 2, this 2 here, we multiply it by y as well. So it becomes 4y. So it means here we're having plus 4y. Then the last part, we're squaring this, it then becomes y squared. It becomes plus y squared. And from here, I can write this in a standard form where I group the like terms. I'm going to take every term in the left-hand side, in the right-hand side, to go to the left-hand side. So I'm going to start with the y squared. I'm having 5y squared. I'm going to take this to this side so that I'm having y squared minus 5y squared minus y squared, and that should give me a 4y squared. Then I'm going to take this to this side. I'm going to then have 10 minus 4y, and these two should give me a 6y. Now when we combine these two, they give me a 10. So I'm going to take the 10 to this side, it becomes a negative 10. And there's no any other numbers this side, so I'm going to have a negative 10 is equal to 0. When you look at this, these are multiple numbers to each other. In other words, I can reduce them by dividing by a 2, because a 2 seems like it's a factor in all of them. Then when I do that, I'm going to have a 2y squared plus a 3y squared, because 6 divided by 2 is a 3, and then here we're going to have a minus 5 is equal to 0. This helps me to factorize this really easy because the numbers are now reduced. My factors will be very easy. So again, I'm going to have a 2y and a y here. And the factors of 5, the simplest ones that I'm going to use is going to be a 5 and a 1. A 5 and a 1. And I can see that if I put the 1 this side and I put 5 this side, it will work out really well for me, because the 2y times 1 is going to give me a 2y. And then the 5 times y is going to be 5y. And remember, I need to combine these two so that they give me a positive 3. For them to give me a positive 3, it means this has to be negative and this has to be positive. Because now if you say negative 2y plus 5, you then get a positive 5. But you must remember that this 2y was a result of 1 here. It means here I'm going to have a negative and I'm going to have a positive here. And of course, if you multiply the 5 and the negative 1, it gives you negative 5. So those are my factors. And this would mean that y is equals to a negative 5 over 2, or y is equals to a 1. But you must remember that here we are solving for x and y simultaneously. So that means I can say substitute the value of y into one of the equations there. The easiest one to use is equation 1. And when I do that, I'm going to say x is equals to, remember equation 1 was defined by this. So I'm going to put the value of y here. So this means now here we are going to have a 2 plus, then we're having a minus 5 over 2. Remember, I'm starting by putting this. Or we're going to have x is equals to a 2 plus the 1. So I'm saying, I'm taking this one here, I'm putting it in there, and this will definitely then give me is a 2 negative 5 over 2, and this should give me a negative 1 over 2, a negative half. Or we're going to have x is equals to a 3, and those are the two solutions that we have. This question is really out of 6 marks. I would believe that the first mark you will get from constructing these equations from weights to equations and labeling them as equation 1 and equation 2. The second mark will come from doing your correct substitutions, writing this in standard form, factorizing, and you're going to get a mark for finding the value of x and y. This will give you 1 mark, and also finding this will give you a mark, and it's a total of 6 marks. That's the end of question 1. My review, well, I think the examiner this year was really fair, and this was straightforward questions. They were not really difficult. They didn't even put a tricky question for you this year. All these questions were just basic algebra questions. So I think on this one, if you have studied, you should have done really well. You could have taken a total. Maybe because we always do mistakes as human beings, you could lose 2 or 3 marks from doing mistakes, writing negative weights, a positive, things like that, or punching a wrong number in a calculator. But there wasn't really anything difficult. I hope you did well on this one. Stay tuned for question 2.